So this here is my 3D printed half-scale rx7. The 3D printing done in the last episode, I've just finished off this side. We need to talk about what to do with the motor. Small rotaries are hard to find and they're actually not very powerful. So I'm going to go with an electric motor. It's going to be pretty dumb, so I'm going to have to do some other things to make it cool. So stick around and find out. We are just starting off where we left off last time. I am moving this axle and cutting the end down, and I've got to flip this around so I take this bearing right off. The axle's cut down and back in for now, along with a fake 3D printed sprocket. More on that later. So these go-karts kind of have weird steering. Ackerman's steering is usually these points will point towards the center of the rear axle, which these don't. They are pretty much straight. The Ackerman's all done on the pivot here. As it flops around, the inside wheel turns sharper than the outside wheel, which is great, but if you want to do a bit of drifting, you kind of want both wheels the same. Otherwise, when you're sliding sideways, one wheel's scrubbing. So I 3D printed up this little number here to make it a single pivot. Alright, with that like that, now both wheels move parallel. So something I thought would be cool is having remote control. I could use this motor here as the steering motor. It's pretty big, but it'll be nice and fast and powerful for the steering. I have this here, it's an ESP32, which I can connect up to the PlayStation controller. So hopefully I can use this to steer that. So this here will tell this here what to do. So I've got to connect all this together, and let's see if this is going to work. Okay, I've been on the computer soldering this stuff up. Left and right steering off a controller, PlayStation. How cool! So how it works is this little thing here is the ESP32, which is like an Arduino but more powerful, and that's wired into the PPM of the 75100 VESC. That sends a signal to here, and you get AI to write a code on the computer that makes it all happen. But as you can imagine, it's not as simple as that. It takes ages. It took even longer because this controller here doesn't work. It runs the motor, but the throttle signals don't work on it. I think it happened when this happened. Oh! So regular viewers of my channel will know about this big wheel motorbike I've made here. 35-inch tires on it and electric QS138 motor, and it's also got another wheel. It's also got another motor at the front here, so it's two-wheel drive. I've already pulled the battery out of it, but I'm going to pull the controller and the motor out for testing because I can't afford to buy another controller right now, so I'm going to flog this one. And I can't even ride this right now because my shoulder's still recovering, so it'll be a while. So until I can find another controller, I'll use this one. Alright, controller is out. Got to get the motor out now quickly, but it's starting to rain, so let's get that done quick. The QS138 is now out. Man, you forget how heavy this thing is. Okay, we've got the far driver controller up here, the QS138 motor down here. Nothing. Alright, after some intense arguments with AI, we got it working. Let's see if the steering will work as well. Oh, is that... Oh, still working. Whoa! Man, Okay, it's all working, but it's just wild amounts of power. I've 3D printed this gear here to go onto the go-kart's drive shaft. Then this here, I've made a gear on here and a little frame that will slide over the drive shaft. The problem is this is bang on 20mm and the drive shaft is like 20.05, so it won't slide over. And I also need to hold this wiring. So then I made this one here that can bolt into, and I'm just going to run some plastic bearings that I can change out when they wear out. So let's swap all that over. So that's going to be my steering, left and right. This motor is super powerful though. This is about the same power as Painted Machine's Sax rotary, which is sad because I'm just using it for the steering, but it's what I got. So I'm going to have to dial it back a bit to work the steering, and I might have to put some limit switches or something on. Now I'm just trying to turn this thing down, just dropping back the duty cycle, see if I can slow this motor down because it's just so crazy. It'll blow itself to pieces. It's way more docile now. See if this works. That steering works all good, but I want to be able to match it exactly to where the position of the stick is. And now it's just working on resistance, how much power I put in. So I've got here is a little potentiometer, and I 3D printed this. It's got a tiny little 2mm hex on here that fits into there, which goes into this thing, which I can then put on the nut on the end of this shaft here, and I can use that when it turns to measure where it is. Let's wire that up. So I've got the potentiometer mounted on the end of the shaft now for the steering, and that is wired to the ESP32 little computer thingy. And now when I turn the wheels, it gives me a feedback reading to the computer. The new code is in. Connect the controller. Not much happening. Okay, if I move the pot, it does try to match it. So if I zero it there, sort of near center, then use the controller, still nothing. I don't know, I don't quite like this idea. I can see myself going through some integration hell, so I might change up the method a bit. I'm just writing code real fast. Okay, I've got a much simpler code going now. So if I go all the way, it hits a limit switch, so it's not trying to fight anymore to go further, and it will still return. Same as the other way. So I've got a digital limit switch using the potentiometer. It doesn't auto return, but since there's so much like I keep forgetting what the word is, backwards slope on here, like is it kingpin or caster or something like that. When the wheels are on the ground, it returns to center really easily. I'll show you in a minute. So there we go, it mechanically self-centers itself, which is great. It'll do it even more once there's some weight in there. Well, pretty happy with the steering now as far as the programming side of things going. I just need to mechanically brace this motor a little bit better. I've only got one brace on one side, I need one on the other side as well, but I'm sick of working on that for now. This video is sponsored by PCB Way. Look what's come just in time. How good. Laser cut, folded. Let's see if they fit. Alright, bolted that up, it fits perfectly, which is great. And it fits the tube really well as well. That's going to make it easy to weld on. Great job, PCB Way.
I'll just show you guys a quick demo of how you can make your own sheet metal parts. I just start off in solid mode, do a sketch, make a 2mm thick plate. Then you switch over to sheet metal rules, convert to sheet metal. Then you just click this flange tool and you can make bends at whatever angle, and it will follow the bending rules, so it will be exactly how it will come off the folder in the factory, because they all use the same bending geometry. Then you just save it as a step file and head over to PCBWay website. And in the CNC and 3D printing section, click on that. Then you just go to sheet metal, upload your step file, and then just go through, select your materials, select your quantity, add a description, and you're ready to go.
You want to make sure when you're making something out of sheet metal that you're going to fold and your holes are close to the edge. You make the holes a little bit bigger. So this is for an 8mm bolt, I made it 9mm. Just because the holes usually distort a little bit. These have actually stayed pretty good, but that one has distorted slightly. So obviously PCBWay also makes PCBs, which I've basically made here, but this is like a little dev board that you just solder the different wires together. I could get this designed into a proper PCB, but I have to learn how to do it. You guys let me know if you want to see me learn to do that. And let's try and get this motor mounted to the back here. I've got this stainless 25mm tube that slides inside the frame, which is going to be perfect, because that way I can I might use like a turnbuckle up here or something, because it's going to be a lot of load that way, and I can use that to adjust the chain tension. So I'll just let's get that done, eh? I might actually do some welding for the first time in nearly a year. The motor mounted here. Let's see if this slides into the chassis. It should do. Yay, that all works. One problem though is this motor's running backwards. Probably looks backwards on the camera, but it's going the right way now. It's as simple as opening the app and pressing change direction. How good. Everything's wired now. Throttle, brake, then we've got reverse, and steering. Alright, time to make it all look a bit nicer. There we go, wheelbase extended. So this should fit the body.
The 3D printer's been running non-stop in the background, printing out the other half of this car, and I've been soldering some of the pieces together when I have a chance. But yeah, it's a pretty low labour setup. You just got to keep filling up the printer and taking the prints off.
There's the left side that I made in part one, except the bumper's gotten a bit messed up from the sun. And while I've been working on all those electronics, I have printed off the other side. There's the rear window. There we go, got the body mostly all tacked together now, but still pretty weak. So I've just gone through these front windscreen pillars here and like plastic welded some little thingies in here to hold the wire in, and just done a few little stitches on the inside where I couldn't reach. But thankfully this is actually strong enough to pick up now.
Hey Daniel, I guess it's time to show you an update of where I'm at with my RX7. So I've got all the body folded up and temporarily tacked in place. I've tried, I can still get in through the door, so that's a bonus. And I've been working on the, how it's going to look with the wing and wheel flares, stuff like that. Not much further forward in the way of chassis, but I have been messing with drivetrain and stuff. But you have to go and check out my my next video to see what's going on there. Now, we got to get a move on. We only got 4 weeks left till Mad Mike's Summer Bash, so pressure's on.
got this back window in. I actually modified this so it's a little bit higher, so I've got more room for my head. As you saw in the last video, I barely fitted in this thing. I got a little bit carried away with the grinder down here, so there's a bit of a massive gap to fill, but the fiberglass will take care of that. One other problem is the roof is quite ripply. Any flat panel, this whole thing's printed out of 1mm thick, but any flat panel needs to be printed thicker, so I wish I had made the roof thicker. The sides are alright because they got a curve and they stabilize themselves, but the roof needs to be way thicker. Alright guys, I'll end this video here. Thanks for watching. Next time probably some fiberglassing on the body and other cool stuff. So thanks for watching, see you next time.